big data, or the terminology big data. Data on its own is actually relevant to or relating to the information that is actually captured. I will just use some typical examples. Probably there are some of you that are working for tertiary institutions or even private companies or any other firms or even municipal sectors. With regards to data, we can actually refer to whatever information that the company is storing. All companies, they do have computer storage. We've got some data that is stored there, some information relating to all of its employees. We've got some data that is stored for colleges or universities, particulars of students, marks of students, that kind of thing. That is what we call data. All the information that is stored about a certain aspect in a company or a firm. So looking at big data in the era that we're living in, there's quite a lot of information that companies requires as far as data is concerned. But the question is there sufficient space for that data to be actually stored? Let us go back to the previous areas. There were times where we used to make use of floppy disks. The floppy disk, I can't even remember how much of space a floppy disk can store. Then we started using memory sticks, those flash. We started using compact disks to store data. So that is the era of data moving from back in the days. If we can look at data in terms of sizes, if we can look at data ranging from small, we can refer to data as megabytes or kilobytes. Moving to big data, that's where we're getting gigabytes, where we find flash sticks with 5 gigabytes, 16 gigabytes, 32 gigabytes. Then moving on, we get terabytes. That's where there was an introduction of what you call, there was an introduction of hard drive, external hard drives. Okay, and then there are also other larger or bigger amounts of data. But now, in the era that we're living in, we've got something called cloud. Besides storing our data on hard drives, we've got something called cloud, where data is just stored somewhere up there, but you can retrieve it at any time. Okay. So what I'm going to do now, I'm going to share a video that is actually going to introduce big data to you, now that I've actually laid out something about big data. Okay. Okay.
This video will...
Okay.
Rocky. Cover the characteristics of big data.
Let me just start that again.
This video will cover the characteristics of big data.
Honestly, I saw this on E. I definitely didn't watch this by myself, but I wanted to be Rocky though. He's cool.
I literally remember watching it on E.
Yeah.
Felix, can you mute this person, Galaxy S8?
Okay, let me sort about that, guys. One of the challenges that we will be having, please guys, just work with me. Just mute yourself when you're not talking, because that is actually going to distract the lesson, and it's gonna actually make us having to stay long for the lesson.
Easier and easier.
I will just start
And
this one
measurement
again.
is such big. This video will cover the characteristics of big data. I'm going to start with the drivers of big data. It can also help us understand
Hi, Felix. We can't see the video.
Oh, okay.
storage of data is big.
Okay. What about that?
Unshare and share your screen again.
Okay, okay. Okay.
This video will cover the characteristics of big data. I'm going to start with the
Just
drivers
hold
of
on.
big data. It can also help us understand this. We've seen a proliferation.
There we go.
In big data. This video will cover the characteristics of big data. I'm going to start with the drivers of big data. It can also help us understand this. We've seen a proliferation of big data for several reasons. Storage of data has become easier and cheaper, especially with cloud storage. Computing power and speed have been increasing exponentially since the 1950s, making the analysis of big data and the processing of it easier and easier. And measurement. We are measuring so many more things. We've seen in the Internet of Things that the Internet of Things alone is expected to exponentially increase the amount of data we actually measure. And we've also seen an exponential growth in what's called unstructured data, textual data, perhaps from social media or other internet sources, pictorial data, and video data. These are hard to analyze, they act differently, and we need new approaches. So big data is often described through a series of words that begin with V. There's three big ones, and they have remained. The first is volume. Big data generally implies quite a lot of data. When I say quite a lot, we'll look at it later, but it can be extraordinary amounts of data. It's not necessarily volume though. The second problem that creates big data problems is velocity. Data that arrives at us fast. I've mentioned before that banks have to look at credit card transactions as quickly as they arrive to try and ascertain whether they are fraudulent. It doesn't become a volume problem in that scenario. The issue there is the speed of the data. And thirdly, we've been talking about varieties of data. Unstructured data, all sorts of data from IoT, internet, etc. Now we're going to unpack this in a bit more detail, but varieties of data create a big data problem for many reasons. There are many of these that we can look at. Big data is a complex topic. Some people have generated as many as 42. But I'll just do another thing. Big data creates veracity problems. For example, if the same individual appears in many places with maybe different names at different ages pictorially, how do you put that person's identity together, that person's data, into one integrated individual record? The problem of veracity. Variability. Sometimes data has massive peaks and troughs. Many of you will shop on a Black Friday and you will see that e-commerce retailers struggle to keep their platforms running.
Felix, please mute your mic.
Data is data we believe has a lot of value, and it needs to have value in order for us to treat it as big data. So we start off with the volume problem. Let me just give you some examples. These are at the tip of the digital tree, if you like. And not all businesses have this kind of volume, but it's worth looking at what is possible. So to start off with, across the data universe, an estimated 90% of all the data we've generated in history was just generated in the last 5 years. Imagine what the next 5 years will bring us. We launch IoT and many other things. Staggering amounts of data. We think of Google. Google generates, as of the last time I looked, about 1.2 trillion searches per year. Now, that doesn't sound like a lot, but consider that algorithms pumping with artificial intelligence, looking up vast amounts of hits. It's an incredible amount of data. Facebook, as of 2016, had 26 billion images in it, 2.5 trillion posts. Imagine the storage required for that. I mentioned before with, say, IoT. A modern aircraft has 10,000 sensors just in the wings. It's expected to produce about 7 terabytes of data a day, a staggering amount of data. The Internet of Things as we continue, a lot of data. I'll switch over to variety. We can see on the screen the vast numbers and varieties of data that we can generate, from documents to, of course, the web, to machine logs and web logs, business applications, sensor data, as we've discussed many times in IoT. It's an absolutely massive amount of data. At the top, we see as well social media, user-supplied data becoming a bigger and bigger part of the data mix. I've added a slide that combines concepts of velocity and variety. Facebook, 31.25 million messages per minute, 2.77 million videos, 1.2 million photos. That's all per minute. Can you imagine the amount of processing and just storage that's required for that kind of velocity? On the right, you see a projection that by 2020, every person will produce about 1.7 megabytes of information per second per person. It's a staggering amount. At the bottom, we see a couple of interesting ones. Google, again, search queries, just massive velocity. I like the one in the middle at the bottom. YouTube uploads about 300 hours of video every minute. Again, can you just imagine the processing required? There's a lot of value, we think, monetizing and actioning the analytics behind big data. Forrester says 74% of companies say they want to be data-driven. But a quarter of them really, or just a bit more, are actually using analytics successfully in this way. It's hard to estimate exactly how valuable data will be when we haven't analyzed it, but here's a bit of an estimate for you. What you see in this graph is the amount of actionable data within the next few years.
Felix, we can't hear anything. You muted yourself.
And they essentially just put the two together. Amazon doesn't sell anything. It does do logistics. But at its heart, Amazon sells data. So is it big data? Well, it's a subjective question. Volume alone is not enough. Modern day computing can handle lots of data. But perhaps one way to think of it is in these combinations. Volume plus velocity, we've seen that. More volume and variety. volume and velocity and variety are all combinations that can lead to big data. But perhaps the most telling way to tell, and you might say this is my opinion, it's an old controversy with a simple answer. Big data requires new technologies and new skill sets, new analytical approaches. So we don't focus necessarily on the attributes of big data. It's all about, are you actually needing the technologies and the skill sets? If you genuinely need them and you're willing to spend the money on them, you might have big data. And so those technologies are the focus of the next video.
Okay. Thank you. I hope that was at least helpful to you, so that you know what is actually what big data is. Okay. So let me just share the study material. There are those technicalities going there. Is the screen big enough for everyone to see? The screen that I'm sharing. Anyone? Okay. Let's hope it is. Now, today's session we are going to cover what is big data. I've actually just introduced big data to you. We are going to cover big data technologies and applications, and then we are going to cover big data solutions. Okay, on behalf of Huawei Big Data Solutions. Okay, now big data is a country strategy for all countries. Group of 8 has released an open data charter, which is widely known as G8. The UK government released the capacity development strategy, which aims to use data to generate business value and boost the economic growth. Well, a lot of companies, like I've introduced, I've actually mentioned before, they are completely dependent on big data. To be more specific, especially the banking sector, they are mostly dependent on big data. We will learn more about that as we continue with our session. Okay. Implementation of the National Big Data Strategy. Implementation of the National Big Data Strategy is to actually accelerate the construction of a digital China, which will involve the following tasks. Well, I don't mean to be political or anything, but China is one of the countries that have the most technological advancement, because big data is one of their national strategy of actually changing our daily technological life. Okay, so it is to promote innovation and development of big data technology, build a digital economy with data as a key enabler, improve the country's capacity in government with big data, improve people's livelihood by also applying big data, and also protect national data security. Most important one, the national data security, especially in the banks. The banks, they've got more information regarding you and your personal accounts, your finances. They even have your credit background, etc., etc. That is all part of big data. Now, looking at big data as a definition, big data is data sets that are so voluminous and complex. That is traditional data processing application software inadequate to deal with. Now, if we think of big data, we should always think of the 4 V's. My friend on the previous video, did mention the 4 V's. And those 4 V's that we mentioned was the volume, which is mentioned here again. Mentioning volume is actually referring to the amount of data. The amount of data that is actually required, like I've outlined before. There's quite a large amount of data that needs to be stored and needs to be also utilized. And then you also mentioned the variety. That is the type of data. There are different types of data. That is what is actually saying by saying variety. And the velocity. This is one of the major concerns now. Because looking at big data, the bigger the data is, the larger the space it requires to be stored. And once there is a lack of space and there is more data, then we're going to have another problem of velocity, speed. Surely some of us do notice maybe our computers, maybe when they overloaded, there's too much data and they start snaggering and the processing speed is very poor. So with velocity, there's also something called 5G, but it doesn't form part of this learning session. It's a course on its own. 5G is actually actually an improvement in terms of making big data possible. So as long as there is enough velocity, then there will be a better storage for big data. There won't be any limitations. Okay, and then there is also value, low data, value density, with regards to having to store more data, but using a small capacity. But at the end of the day, we know that there is a big value for that type of data that is stored. Okay. Let us have a look at the sources of big data. Someone is muted.
Hello, sir. Afternoon, sir. Can you zoom your screen? Can you zoom your screen a little bit?
Sorry?
Can you zoom your screen a little bit?
Oh, okay. Thank you, Tamula. I hope that's okay, because that's as much as I can go. If I go bigger than this, some of my displays here will not fit into the screen that I'm sharing with you guys. Okay, looking at the sources of big data, there are more than 200 million messages every day. There are 2.5 billion smart users worldwide. There are more than 300 million active users every day. My friend there on that video that I showed you earlier on, he mentioned something about Facebook. Facebook is one of the data source that uses much data. On our daily life, we're using Facebook as our social network. Okay, so these are all the sources of big data. Okay, right. Cover this. Okay. All businesses are data businesses. I've mentioned that earlier on. Your business is a data business now. Data about your business customers is as valuable as your customers. Streaming data is a business opportunity. Data is a platform, and we need to make sure that we keep data moving all the time. Now let us look at the differences between data processing in this big data era. The big data era we are talking about is the era that we are living in now, the fourth industrial. Okay. Now, from the databases to the big databases, we need to look at this as using an example, the pond and the sea. If we're looking at the pond, that is where we find less fishes, and there's even less fishing to do. Obviously, there's less fish. Looking at the sea, more fishes, meaning there's more fishing to do. Okay, so we are looking at data in that sense, looking at data as small and looking at data as large. I did mention earlier on that if we are looking at data in a scale, we are looking at data in megabytes in a smaller scale. But if we are looking at data in a bigger scale, we are looking at data as gigabytes or terabytes or even petabytes. Okay. Now, type of data could be either single or else it could be diversified. If it is diversified, it could be structured, semi-structured, or even unstructured. Now, we're going to look at the relationship between modes and data, which is something that we're going to talk about at a later stage. Modes come ahead of data, but then data comes ahead of modes. Okay, so the object to be processed here is that data is fished in ponds, while big data is actually fished in from the sea. Okay, the processing tool for the small data, one size fits all, but the processing tool for the big data, there's actually no size that will actually fit all of the data that will be involved. Okay. Now, the big data era, the one that we are currently living in now. China's net sizes rank the first in the world, and the data volume generated in each day also surpasses others in the world. Okay. Now, more than 50,000 gigabytes of data is generated per day, 40 million gigabyte data storage for volume. We use cameras. The cameras, they work at a rate of 8 megabits per second. So in that way, there is actually 3.6 gigabyte data that is actually generated per hour. Tens of millions of gigabyte data can be generated each month in one city. Okay. Now, 1 billion gigabyte data in total. 1 trillion web pages are actually stored. Okay. And then in hospitals, we also find big data. There's plenty of machinery that is actually used there in hospitals. The amount of CT image data generated for a patient can reach about a dozen of a gigabyte. Tens of billions of gigabytes data in a country needs to be stored in each country. So you can just take this into what we are actually experiencing, the pandemic. Hospitals around the whole world have been filled with patients, and there is so much data that needs to be captured for each and every one of those patients. So you can imagine how much data is required for the hospitals, the medical sector. Okay. Now, the big data era, what is it actually going to do for us? Going to decrease the hardware costs. I did mention earlier on that using big data, in the past days that we've been living in, we were using floppy disks. There was a lot of hard drive. And in order to store data on that particular hard drive, even a memory stick, in order to store data on a memory stick, I need to buy a memory stick first. So a memory stick is actually a hard drive. So with the new era of big data, since big data would be stored on cloud somewhere out there, where it can be accessed without using any hardware storage, then in that manner, in that sense, there's going to be actually a decrease in terms of hardware cost. In terms of speed, acceleration of network bandwidth, I did mention that earlier on, because I'm actually reflecting on the V's now, the velocity, acceleration of network bandwidth. So there won't be any staggering of network. I'm sure we are all irritated by that when the network begins to stag, and that is all because of the amount of data that is contained that we are trying to store. But big data is a solution. Image of cloud computing, I've covered that. Cloud storage without having to use any external hard drive, but it is stored somewhere out there. Popularization of intelligence terminals, e-commerce and social networks, comprehensive application of electronic maps. If you are looking at the electronic maps, we can just simply relate to Google. Google is actually Google Maps. Sorry, Google Maps. Google Maps is actually comprised of quite a large amount of data. Having to switch on your phone and type in your address and boom, just like that, you'll be able to find the directions and you'll be able to navigate yourself to the particular location. Okay, that is all because of big data. And also, we cannot live out the Internet of Things. Okay, because everything that we're actually using now is modernized in terms of technology. Okay. Right. Now, let us look at the relationship between big data and us people. Okay. Now, this is what we all need to know. Humans are actually powerful than big data. Okay. What am I saying by highlighting the point? Big data cannot make any decisions. Big data cannot actually discover knowledge. Big data cannot actually export a road. Who is actually responsible for doing that? It is us people. Okay, because we actually need to make decisions. What do we need to store? Who do we need to actually link that the data that we need to store? When we need to retrieve the data? So if I'm saying human is actually powerful than big data, that is exactly what I'm trying to say. So in that manner, I'm actually trying to elaborate the relationship between big data and people. So if all you have is a hammer, everything will actually look like a nail. Today, it seems like big data is miraculous and impossible. However, do not take big data as an all-around way to solve all problems in the world. Human thought, personal, cultural, and behavior notes, as well as the existence and development of different nations and the society. Okay. Now, what is it that big data cannot do? Okay. Big data cannot do, one, cannot substitute the manager's decision or making capabilities. Like I've actually mentioned before, we're actually powerful than big data. Okay. Big data is not only a technical issue, but also a decision-making issue. Data onboarding must be pushed and determined by top leaders. Okay. Number two, big data cannot substitute effective business models. What does that mean? Balance cannot always be obtained with big data. So, in other words, whatever business that we are involved in, it will entirely depend on us, how we actually, what model we're actually using in order to make the business successful. Okay. So whatever information that we need to store, or whatever data that we need to store, it will all depend on what business model that we have for the functionality of the business. Thirdly, big data cannot discover knowledge aimlessly. Okay, what does that mean? Still, it is taking us back to the fact that human is more powerful. So whatever information that you feed into big data will actually determine what we've actually inserted. Okay. Fourthly, big data cannot substitute the role of experts. The experts contribute greatly to the product modeling, such as IBM, Deep Blue, AlphaGo. The role of experts may decrease as time goes on. Now, we are in the fourth industrial revolution. So, we've been seeing a lot of changes. There are what we call robots. Things are getting computerized. But whatever a robot can do, we know very well that you and I, we are the actual source of what the robot can actually do. So whatever algorithms that are fed onto the robots, meaning what you instruct the robot to do, because you'll be loading data onto it. So in that manner, the role of us as experts, say for instance, I'm an expert, engineering expert, so I'm being substituted by a robot now. That does not necessarily mean that my role will never be required. Okay. But at some point, it will be required because I am actually the source of that skill or expertise. And lastly, big data cannot build a model for permanent benefits. Okay, big data requires live data with feedback. Models need to be updated through lifelong machine learning. Okay, that is actually what big data cannot do. Right. Now, let us look at big data era in terms of leading the future. Data has penetrated into every industry in the business domain. Okay, I'm going to take you through, because I did mention earlier before that most sectors, in fact, all sectors are highly dependent on big data. What do I mean by all sectors? I'll just use a few examples like I've done before. The medical sector, hospitals, the educational sector, the universities, your colleges, your high schools, and even the financial sector, the banks. Okay, so the big data area is actually leading the future. We are going to be entirely dependent on this big data. And it is very important that we know that's how we can actually store big data without having to lose data, because the fear of all business sectors is losing data. Imagine if a bank would lose all the data it has. You knowing that you've got a balance of say 10,000 rand, but only to find that there isn't a proof that you've got 10,000. That doesn't necessarily mean that you actually have 10,000 there, 10,000 rand there in the bank kept for you. It is actually data that you see there on your app. Okay, so it is very important that this data is well managed, well secured, well protected. Okay, now let us look at a proportion of the top 100 industries using big data. 24% of data, which is taking the most slice of big data, the financial side. Those are your banks, etc., like I've actually mentioned before. The bank has the most data, requires more data storage than any other sector. Okay. Then we have the retail sector, your shops, where we have accounts, your Woolworths. It requires data storage as well, knowing how much you owe, you actually owe. Then we have 14% of the city, all the city proceedings, whatever that is happening within the city. Can include maybe the management of traffic lights, CCTV cameras that are monitoring the city. That's all part of the data storage. Okay, medical treatment, 8%. Sports, which is 6%. Your gyms, etc., Vision Active. 4% on the educational sector, and then another 4% on the telecommunication sector. Okay. Now, okay, I'm about to get political again. Big data application, as far as politics are concerned. There is an example of how big data has been actually used. Big data, psychological analysis. It actually helped Trump win America's presidential election. Donald Trump employed Cambridge Analytica Ltd to make personality and requirement analysis on American voters, which acquired personalities of 220 million Americans. Okay, the CIA uses the behavior of giving likes by voters on Facebook to analyze the actual personality traits and political orientation of voters. So that is to classify voters into 3 types: Republican supporters, the Democratic supporters, and swing voters. And actually focuses on attracting the swing voters. So Trump has never sent emails before. He bought his first smartphone after the presidential election was fascinated with Twitter. That explains the reason why he's so excited on Twitter. The messages sent by him on Twitter are data-driven, and they vary from for different voters. So that is where actually big data goes in. Imagine the amount of people that are actually engaging on Twitter and Facebook. So for African Americans, they can see the video in which the flag is called Predators by Hillary Clinton, and thereby go all the way to the ballot box. So these dark posts are visible for only specified users. So politically, big data was actually used there, the benefits. Okay. Right. Big data application in terms of the financial side. We can look at the traditional customers. We can look at new customers. We can look at the traditional finance. We can look at the new financial institutes. So here we actually focusing on the financial side. Basically, we are looking at the banking sector. Okay. Right. Financial case, 4-hour time difference between the East and the West of the USA. So Walmart uses the sales to analyze the results of the East Coast to guide the guides arrangement for the West Coast on one day. So that is actually a finance case for the United States of America. Big data application in education. Now that big data analysis has been applied to American public education and become an important force of education. So we're going to look at 12 aspects. What big data can do, okay, in the educational system. I can just use a typical example. I'm just assuming we do have students here in this session that are actually in the college Tibet sector. The Tibet sector uses, if I'm not mistaken, there's a software or a program that is actually known as Holtec. That program or software manages data for the college. It manages data, for an example, for staff as a method of file management system, where there are personal information, payroll, employment history, IRP5 reconciliations, etc. Okay. Then it also does management of assets. So we've got assets like we've got furnitures in colleges. There are furnitures in colleges. We've got computers. Those computers must be barcoded, and those barcodes would be scanned. And once they are scanned, they are stored on this Holtec asset management system. I'm just touching on a few. Is also enrollment information for each student, their academic performance, etc., etc. So look at big data application as far as education is concerned. Let us just use Holtec as an example. Okay. So on my slide here, we've got academic performance, enrollment rates, dropout rates. That's what big data can actually do now. You don't actually have to go back to universities and check for learners that have actually deregistered. It's even better if it's deregistered. Just students that are no longer seen on the institution premises. So with big data is actually going to be able to actually pick that up. The dropout rates, the rates of admission, literacy, accuracy, homework correctness, hand raising in class. Well, that we can actually relate it to artificial intelligence. Okay, where there are actually cameras that are installed in our tertiary institutions. Question answering times, duration. Okay, that's what actually big data can do as far as education is concerned. Transportation. What can big data do as far as transportation is concerned? Big data, we can actually look at the example nodes of transportation for a distance of less than 500 kilometers. Okay. what example, suitable example can I use here? Okay. Now, with regards to transportation, let me just use the booking of flights. Okay. We book flights almost every day. We book buses, so Intercape, etc. How do you think that that data is actually managed? Having to book and you have to cancel. It's not a task of a human being to know that there were bookings, 59 bookings today, 3 cancelled, and they chose another suitable date or time. That needs to be managed, computerized. But it will all depend on how we actually retrieve the data. So big data is here to actually make that easy as far as the transportation sector is concerned. The tourism sector, the hotels, booking of holidays. Okay. Again, the tourism, bookings of air tickets. You need to know the amount of air tickets that you book for each particular country. Even that way, with big data, it is actually going to be easy for countries to know their current population during holiday peak sessions. Okay. And yeah, the most critical, the government and public security, big data. With regards to government and public security, big data will be playing a very huge role in terms of something called national security. Each country has its own national security, but it is for the state to actually know what they need to know for that particular person. Okay. Whatever that we do, we might think that we are not being monitored. Every time, as long as the government has something on you and needs to access you, big data will also play a role in actually retrieving whatever information. Don't ask me how it actually works, but I am here to actually highlight and outline what actually big data is capable of. Okay. Traffic planning, that will also take us to areas with people flow exceeding the threshold ones. Now, by mentioning traffic, looking at Beijing as a city, Beijing is one of the most industrialized places. Therefore, it's going to be congested because there's a lot of activities that are going on in that particular area. So with big data, it is very possible to actually plan movement around that area as far as trafficking is concerned. Okay. By saying trafficking, I'm not only referring to motor vehicles, I'm referring to any form of movement, pedestrian or even any form. Okay. Right. Big data applications. I did also mention on sports. Okay. They are sport researchers. They need to know if a normal human being can burn this much calories at this particular type of okay. At this maybe doing a particular exercise in a duration of a certain time. You know, what is the actual heartbeat, etc., etc. We've got smart watches now that we are actually using. There are some watches by Huawei. They all part of the era of big data. You can see even these watches, they can actually send information to your home while you're running on the road. Okay, there's quite a lot that big data can do as far as sports is concerned. Even the gyms, they can even create their own statistics, which is the most busiest day of the gym. Like in most cases, most people they usually work out a lot on Thursdays because on Fridays they got most people they got different commitments. Maybe they're moving from one place to another. There's also maybe trends of witnessing a lot of gym activities going on in gyms, going on Saturday mornings. Okay, even with sports, the premierships, the leagues with different countries. That is all part of big data. Even with the gambling industry, they actually used what big data has been collecting from all sporting activities. Okay, those are all capabilities of big data. Okay, now we can take a short break. Your break, let's say 5, 10. You can take a 15-minute break. The time is now 3:10. We should be back at 3:20. Then we will have the last session, so that we'll be able to cover today's objective as planned for this session. Okay. Then you can take a break.
Nancy. Hey, well, people, where are you?
Okay, we should be back now. It's 3:20.
Yes.
Okay, that's good. Our 15 minutes break is over now. It must be noted that it is very important for us to adhere to the times, so that I will not have to add any additional time. Because remember, we planned that we'll be stopping at 4:10. So that's exactly 2 hours. Okay. Right. Okay, moving on. I hope you can all hear me. You can see my screen as well there. Could anyone respond, please?
Yes, sir.
Thank you. Thank you. Let us look at the challenges now that we have as far as big data is concerned. Okay. What we are actually going to do here, I'm going to play another video from my friend there. He's actually going to explain some of the challenges that I actually experienced in terms of traditional data processing. Okay. Just bear with me there, guys. Okay.
This short video is going to outline some of the challenges with
Okay.
big data. Thereafter, we will look at the technologies. This short video is going to outline some of the challenges with big data. Thereafter, we will look at the technologies. Well, we've kind of already discussed some of the challenges. If you think about the data lifecycle, you start with the challenges around actually looking at the data itself. And we've already discussed this. The value, the velocity, the variety, the volume. These are all challenges that we need to deal with. You might add some others. We've talked about veracity, the fact that as you add more and more data, sorting it out, figuring out who's who, being able to spot problems with the data becomes more problematic. At the bottom of that list, you'll also see visualization. Graphically rendering data becomes harder and harder as it becomes bigger and bigger, or faster and faster. But perhaps that's not the biggest challenge with big data visualization. The biggest challenge, in my opinion, is just making graphics that are actually usable. Too many data scientists make graphics that are, in fact, hard to interpret. The second set of challenges is the process challenges. Challenges while you're actually processing the data. What we see here is many. Acquiring the data in the first place, and then just storing it, warehousing it. How do you do that if it's really big data? Do you use your own warehouses, or do you try and go to the cloud? There's many choices to be made. Big data has to be cleaned and what we call data mined potentially, which is looking at it with fresh eyes through algorithms that help to unpack the trends. Big data has massive issues, as we've spoken about, with aggregation and integration across different types. Analysis and monitoring within big data can be a challenge, and interpreting it. We've already spoken about that. And then the management challenges. There's several management challenges. Leadership, for example, is a non-trivial challenge because very often you have to bring on board new technologies and new teams and skills and new thinking mindsets. And leadership often needs to, if you like, push through that expenditure to see the real gain. Sometimes the gains in big data can take a while to realize. It takes a while to get the data to work for you. And in the meantime, leaders need to stick to their path. Privacy and security are, of course, massive. We've seen it with governments gathering vast amounts of data on their citizenry. At what stage are you breaching their rights, their privacy rights? But organizations as well. The big tech firms have embroiled themselves frequently in issues around the security of their clients' data as well as the privacy of their use. So these are issues that we will grapple with as we go through the course in other areas such as the policy parts of the course. Data governance, just making sure that your policies around data are good. Data sharing and information, so many others. Who owns the data? We've already discussed with IoT. Can become a substantive challenge. If you're going to spend money on big data, are you spending money all up front, or are you managing to send it through your operational expenditures? As you do your finance course, that would be discussed. And then the talent side of big data. It's a non-trivial thing. There are serious data scientist skill sets as well as other skill sets required to make big data truly work. So in this final slide, we see the types of challenges that traditional approaches and techniques have with big data. Now, let me just say in advance, the traditional techniques are especially relational database formatting, where you expect all the data to be in neat rows and columns. That's the traditional approach, as well as traditional storage approaches, where we may store stuff on a server or a data warehouse that has limited capabilities to change in size or to take in different data sets. So what we see here is that across all these major V's, at the veracity side, we see that the traditional approaches just don't come close to the kinds of problems we find with the cleanliness or the integration of big data. Especially on the velocity side. Traditional approaches have no real capabilities of analyzing data quickly as it arrives, whereas big data techniques do. In terms of varieties of big data, traditional approaches do not have the capability necessarily of approaching, let's say, textual or visual data and actually analyzing it properly, whereas big data approaches take this very seriously. And of course, on the volume side. We want storage, for example, that is able to be scalable so that as you take on even more data, you can increase the storage relatively easily. Traditional approaches do not have this, whereas the big data approaches do. So with that, we end the challenges part of this lecture, and the next video will talk about big data technologies.
Okay, thank you. My friend there was just outlining and actually making it's clear to us the challenges that we are experiencing with regards to big data. Okay. So far, are there any questions that you would like me to answer? If there are any questions, you can simply give you an opportunity. I will unmute you before I move on to the slides again. Okay. Questions. Right. Going back to the slides. Right. Now, the challenges of traditional data processing technologies are as follows. High cost of storing massive data. I think I've mentioned that before. Insufficient batch data processing performance. That is the speed, of course. Lack of streaming and data processing. I can actually relate to even the Zoom that we're having. If all of us could actually switch on our videos, if I could see all of you, you will notice that there won't be, we're going to start experiencing problems. The whole thing will start staggering. We're going to start having problems. There will be, obviously, because there will be too much data that is actually fed in producing the video. Lack of limited scalability, single data source, external added data value assets. Application of scenario enterprises, big data platforms. We are going to look at operation, management, supervision, and profession. As far as operation is concerned, with regards to the telecommunication and finance sector, there's going to be operation analysis, financial bills, electricity distribution, smart grids. That's where big data is involved. In terms of management on the financial side, financial sector, performance management, report analysis, history analysis, I've mentioned before, maybe your credit record and stuff, social security analysis, tax analysis, your taxation, thereby us, decision-making support, and prediction. That is all big data involved there as far as management is concerned. The supervision, I did also mention that the government, they do not have any restrictions in terms of accessing certain information. As far as supervision is concerned, the government has every right to know everything there is to know about a country's citizen. So we've got information such as public security networking. We've got cell phones that are record here in South Africa. Technical investigation for national security. Some conversations could be retrieved. Some WhatsApp messages could be retrieved, even though we've actually deleted, but it is still stored there on the cloud. That is all in the involvement of big data. Okay, food sourcing, tracing, environmental monitoring, in China, they actually, with regards to banking, the banking regulations, where they have a banking regulatory commission, CBRC. So they make use of big data for supervision purposes. Profession, government is also involved as well there. Audio and video, seismic prospecting, weather, nephogram, satellite remote sensing, radii data, Internet of Things. Now, with regards to monitoring in terms of profession, there are weather predictions which are monitored by satellites that are stationed there out there in space. They've got data that is actually loaded on them. There is also photographic images of moving cyclones, you name it. That is all part of involvement of big data. The government is also involved here. Right. Challenges faced by enterprises, the businesses. We are looking at the small business. Business departments do not have clear requirements on big data. Many enterprises, business departments are not familiar with big data, as well as its application scenarios and benefits. Therefore, it is difficult for them to provide accurate requirements on big data. The requirement of big data, businesses, departments are not clear. The big data departments are non-profit departments. Therefore, enterprises decision makers worry about the low input-output ratio and hesitate to construct big data department. Okay. More challenges, serious data silo problems within, meaning the data storage. Most important challenges faced by enterprises, they implement big data. In implementing big data is a data fragment. In large-scale enterprises, big data types of data are often scaled in different departments, so that the same data within an enterprise cannot be shared, and the value of big data cannot be fully used. So it is very important that each enterprise actually stores their data in a very private space, but they are still having problems since they are not quite familiar with what we call big data. All they can do right now is just the normal storing of data. Okay, so big data needs to be introduced to these enterprises so that they would actually reduce the challenges that they are experiencing. Another challenge, low data availability and poor quality. Many large and medium enterprises generate a large amount of data each day. However, some enterprises pay no attention to big data processing, resulting in non-standard data processing. During big data processing, data needs to be extracted and converted into data that is easy to be processed, cleaned, and also dynamized to obtain valid data. According to data from Sybase, if high quality of data is available, it improves by 10%. So the way we can look at this, it is pointless having to have data. Say for an example, you are running a business and you only pay special attention to data that you only need at that particular time. Okay. There might be cases whereby you need to actually go back and retrieve some data, maybe for specific or for particular reasons. Say, for instance, maybe let's say for an example, the building actually burns down. Now, how are you actually going to retrieve all that lost data? Okay, we shouldn't actually think that the data that we will need is only the data that is saved on computers, hard drives. There should be sufficient storage of data, even the data that we will not make use of in a short term. Okay, so it is very important that data is of good quality. Having low data will actually mean that the data that we have is of poor quality. But with big data, we're going to have a large amount of data. We can retrieve anything at any time, anywhere. Okay. Challenges. Challenge number 4, data-related management technology and architecture. Now, traditional database cannot process hundreds of terabytes of data. Data diversities are not considered in traditional databases. Okay. Now, there's a repetition of information here. I've mentioned earlier that for as long as we still have the ordinary data storage system, we are not going to have much data that is going to be stored. Okay. And we are going to go into, will be in much expenses, the use of hard drives. You understand? But with big data, we can actually store hundreds and hundreds of terabytes of data. So that way, we can actually minimize data-related problems. Okay, as far as technology and architecture is concerned. Data security. Before, I've mentioned it again. Data needs to be as confidential as possible. For all sectors, the banking sectors, the medical sector, the education sector, the data needs to be secured. Okay. Now, when you are just storing data in normal storage, that is not possible to happen. We need to store data in secure places, and that can be possible with big data. Okay. Right. Another challenge, insufficient big data talents. Each type of big data construction must be completed by professionals. Now, again, insufficient big data talent. Now, the experience in big data application, hundreds of thousands of big data related jobs are increased globally every year. More than 1 million talent gaps will appear in the future. Therefore, universities and enterprises make joint efforts to develop in mining talents. Now, by you having to enroll for this course, big data, there's quite a lot that you are going to learn. By the time you complete this course, as long as you have full day attendance, you will be certified, not only as an instructor, but you will also be certified as someone with the knowledge of big data. Okay, this is just the junior phase. Okay, moving forward, we can still advance your skills as far as big data is concerned. That is where job opportunities could be created for us. Okay, I'm also including myself. Right, another challenge, trade-off between data openness and privacy. Today, with increased opportunities of big data application, opening and sharing of data resources has become a key factor in maintaining advantages during data awareness. However, the data opening would be inevitably infringe the privacy of some users. Okay. How to effectively protect the privacy of citizens and enterprises and gradually strengthen the privacy legislation while promoting all-round data opening, applications, and sharing will be a major challenge in the big data era. Okay, that is actually clear. Right. Now, let us look at time analysis. Okay. When you look at time analysis, there is something that we are going to learn at a later stage. Something that is called the Hadoop distributed file system. It is actually known as the HDFS. Okay. So the Hadoop reference practice in the industry, it actually enhances the distribution of Apache Hadoop, which is actually a software. Okay. I will have to get more technical in actually making you understand this. Okay. In memory computing, reference practice in the industry, based on the column-oriented storage powertrain, it uses a memory computing technology to deliver the performance of querying trillions of cell data per second, which is 10 to 100 times of the traditional column-oriented storage performance. So in this case now we are actually on the storage center of this data that we've been talking about from the beginning. Okay, PowerDrill can quickly skip unnecessary data blocks compared with the full scaling performance. The PowerDrill performance is improved by 100 times. Data memory usage space can be optimized and reduced to 1 out of 16 using the compression and encoding technologies. So by encoding, it is actually the memory. Okay, whatever instruction that we've actually inserted for the storage of big data. Like I did mention before, big data, we are actually powerful than big data, because big data will not store itself. Okay, big data, we need to actually combine the data, then we can actually store the data. Streaming computing reference practice in the industry. The IBM InfoSphere Streams is one of the core components of IBM Big Data. It's a strategy that supports high speed of processing structured and unstructured data. Processing data in motion through millions of events per second. Okay, so again here, they are mentioning speed, and they are also mentioning a variety where we've got structured and having unstructured data. Right, more opportunities in the big data era, the one that we are living in. The big data blue ocean strategy becomes a new focus on the enterprise competition. The huge commercial value brought by big data will lead a great transformation that is equal in force with the computer revolution in the 20th century. Big data is offering each field, including commercial, economic, and other fields. Big data is promoting the generation of a new blue ocean, bringing new blue growth point of economy and is becoming a new focus of enterprise competition. Now, what are the talents that are required during the development of big data? Okay. Big data system, which is the R&D. We need the R&D engineers. The big data application development, the apps, big data apps. So there are engineers required for that. The big data analysis. Okay. Those are another talents that are required. Data visualization engineers, data security and R&D engineers, data science research talents. Okay, that is all part of the development in search of the different talents, in order to make big data successful. Okay, right. Moving on, big data solution. Now, this is what we call a Huawei big data platform architecture. Okay. Now, on this is what we call an application service layer, where we have a porter, we have a miner, and then we have a farmer. Remember earlier on, I did talk about the HDFS, which is a Hadoop distributed file system. Now, the Hadoop layer provides real-time data processing environment, which is actually enhanced based on the community open source software. So the data firm here, the data firm layer provides end-to-end data insights and builds the data supply chain from data to information. So the knowledge and wisdom, including the portal of the data integration services, are actually included here on the data firm. Okay. Then we have the manager, which is actually distributed manager architecture that actually administrates the control of distributed clusters from a single point to a system of files that needs to be managed, and also it will also secure whatever information that is included. Okay. The core capabilities of the Huawei big data, that is our big data team. Okay, must be able to use Hadoop, which is the HDFS. Must be able to locate peripheral problems. Must be able to resolve camel level problems, meaning all the outstanding individual. Must be able to resolve problems. Must be able to independently complete camel level development for critical service features, and must be able to take the lead in the communities and develop future-orientated camel features. And lastly, must be able to establish the top projects that are adaptable to the ecosystem in the community. So that is actually what the big data team should be capable of. The main capabilities. Okay. Big data platforms, the partners from finance and career sectors, the industry and commercial bank, China merchants in the banks, Pacific insurances, China mobile, China unicorn. So actually 50% of the top 10 customers in China's are comprising of the China's financial industry. And then the top 3 will be the China telco. Okay. So, just to wrap up, in summary, these slides, they've actually explained to you the big data era from the older times where we had floppy disks, the evolution up to the current big data era that we're living in. Okay. The application of big data in all walks of life. We've mentioned the banking sector. We've mentioned the sports. Okay. The opportunities we've mentioned can create greater opportunities, the use of big data, and also the challenges. We've covered a few challenges as far as big data is concerned. Okay. And then I just highlighted also the Huawei, what is the actual solution? Because the Huawei is actually coming up with a solution now to big data. Hence, the reason why we're actually enrolled for this course, because we need to actually understand what big data is. Okay. Yeah. So, just a small quiz here. I would like us to participate in this small quiz. Where is big data coming from? And what are the features of big data? So I'm just giving you a platform now to actually participate so that I will know that we are still engaging on the lesson. Any volunteers? Okay, no volunteers. Okay, right. The big data, it is coming from the different sectors. It can come from the bank, but who actually feeds data? We generate data, then we store data. Then looking at the features of data, of big data. The features of big data would be we are able to store large amounts of data. We are able to retrieve. We are able to gain access to better processing speed. Okay. That was what the 4 V's were actually explaining big data. So those, they form parts of the features of big data. Which social fields can big data be applied to? We did mention Facebook, Twitter, even on Instagram, even though we did not mention on this lesson, but those are all social fields. We've got WhatsApp now. That's all part of data. Okay. Right, and then what is the Huawei big data solution called? The big data solution for the Huawei. Okay. This is the big data solution for the Huawei. This is where we see HDFS, your Hadoop distributed file systems. This is where we can find all the solutions for the big data. Okay. That's it for today. Now, on this study, material that was supplied to you, you will see that there is access to training materials that needs to be downloaded. I'm not sure whether